My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 470. In this lecture, we will try to understand metrics for clustering. The data set given for clustering is xi. What does it mean? There are no yi's. The question here is, how do you measure how good your clustering is? What are the performance measures or metrics which measure how good your clustering is? It is very important problem, because for classification and regression we have seen a bunch of metrics and all of them use your yi's. Yi's are also called class labels in the case of classification and regression values in the case of regression. In some books, they are often referred to as ground truth. Your job is given x, we have to determine what is y is. That is our job. That's what whole classification and regression all about. But when you come to the area of clustering, all you are given your data set capital D is xi and there are no yi's. The big question is, all the techniques that we learned for classification like AUC, log loss, precision, recall, none of them will work because all of them need yi's. The big question here is, what type of measures can we employ for clustering? Before we go into exact metric itself, let's understand the geometry. Let's try to get geometric intuition on what is good clustering result. Let's understand this first. To understand this, let's draw simple geometric diagram. Let's assume these are clusters of points. This is feature 1. Which one? This is, let me say, this is my feature 1 and this is my feature 2. Suppose, just for simplicity, I have bunch of points. This is I have bunch of points here and there are no true class labels. No true class labels. Isn't it? There are no true class labels here. All points are same color, isn't it? Because you don't have yi's. You have this data set. What is my data set? My data set is D equal to xi. There is no yi's, isn't it? Where xi belongs to R2 with feature 1 and feature 2. This is your scatter plot, is it not? This is your scatter plot of your data. As I told you earlier, what would a small 5-year-old kid, I will if I tell him to group this into two clusters, typically we call it as k clusters. Typically we call it as k clusters, isn't it? If I ask a 5-year-old kid group this into two clusters, what would a 5-year-old kid do? All these points, just see, all these points are one cluster and all these points are in another cluster. That's what a kid would do. Geometrically speaking, argument here is this. Let's call this is cluster C1 and let's call this is as cluster C2, isn't it? Cluster C1 and cluster C2. So all the points which are there in single cluster, which are there in single, these are the points which are there in single cluster are called intra cluster. This is known as intra cluster. There are two words, intra cluster and intercluster. Intra-cluster means, what is your intra-cluster means within a cluster Intercluster means across the clusters or between the clusters. These are important words to remember: intracluster and intercluster. So one thing that they have done this, if you think about, they grouped into clusters such that intra-cluster distance is small, such that intra-cluster distance is small, which means if you take any 2 points within a cluster and if you look at the distance between the points, take any 2 points in the cluster, in any cluster, the intra-cluster distance is kept small while inter-cluster distance is large. What is the intercluster distance here? The distance between 2 points which are in two different clusters, that is intercluster distance. For example, if you take a point here in C1, if you take a point here in C1 and another point in C2, so this distance, let me say, so this distance, this line is called intercluster distance. Intercluster distance between these points and this point, this point, the intercluster distance should be large and intracluster distance should be small. This whole thing about intracluster being small and intercluster being large, this is the basis, this is the core idea how we measure the clustering effectiveness. This is the core idea for measuring the effectiveness of clustering. In ideal world you want your intercluster distance to be very high and your intra-cluster distance to be very low. There is one metric called Dunn index. What it does is exactly Dunn index, often referred to as capital D, which is maximum or I comma j, numerator is dij. Suppose if you have k clusters, C1, C2, Ci, Cj, so on Ck, your clusters, what is this numerator? We will try to understand numerator and as well as denominator. I will explain each of these terms. The first one here is max of I comma j. What is the first one? Max of I comma j dij. This is this capital D. This capital D is numerator, is different from capital D dash, which is in denominator. This D is basically, what is this capital, what is this D? This D is different from this D dash. What is the difference? The D is basically the distance between cluster Ci and cluster Cj. Now your question could be, how do you measure this? What it says is the numerator is basically the maximum over all I comma j. It is maximum intercluster distance. What is the numerator? Maximum intercluster distance. That's the numerator. Now let's come to the denominator. This d dash here is intracluster distance. What is my d dash? Is here intracluster distance, isn't it? We will see how to measure the intracluster distance also. So ideally this value, which value? This value means numerator should be high and denominator should be low. So if the Dunn index is high, it implies very good clustering. In the Dunn index, we said that we want to measure the cluster distance between Ci and Cj, that is numerator. And how do you measure it? Similarly here, intra-cluster distance, denominator, how will you measure? We will try to understand. Let's see how to measure it. Let's actually draw a diagram to measure it. Let's assume we have feature 1. Let's assume we have feature 1. This is my feature 1 and this is my feature 2. And you have your points. These are the data points, isn't it? These are the These are the data points. Yes. So in Dunn index Dij, distance between Ci and Cj. What is this distance between Ci and Cj? Distance between Ci and Cj, farthest points, which means take a point here, take a point here, and take a point here. I am taking another point here. Isn't it? How do you compute this distance? This is the distance, isn't it? Take a point here and also take a point here. Also take a point here. This is another distance. Let's call this is let me say this is D1. Let me say this is D2. Let me say this is D3. Isn't it? For every points, I can say keep doing for every point. Keep doing for every pair of points. Keep doing for every pair of points, where one point is from this, one point is from cluster C1. Let me say this is C1, this is C2. One point is from cluster C1 and other point is from cluster C2. Compute the distances. Just compute the distances D1, D2, let me say D3, so on, isn't it? And take maximum distance. Just calculate max of this D1, D2, D3, so on, and take maximum distance. We most likely to get this distance D star. D star means optimal distance. D star between this, which one is maximum distance? This is the D star. Your D2 is D star, isn't it? What is D star? Distance between the points are this point, farthest distance, I can say Dij. Here in the numerator is the distance between cluster C1 and cluster C2, such that it is the distance of two farthest points. Your D star is distance between two farthest distance between two farthest points. So it is the distance between two farthest points, such that first point lies in cluster C1 and second point lies in cluster C2. That's how you measure it. That's what about the numerator. What about denominator? Denominator says within a cluster. Let me say within a cluster C1. What are the farthest distance? This is the farthest distance within a cluster C1. This is the farthest distance, isn't it? This is the farthest distance in cluster C1. Similarly, in cluster C2, this is the farthest distance. Let me assume this is the farthest distance. So it says for every cluster, take farthest distance and take the maximum among them. Let's call this distance, let me say this distance, this distance is D1 dash, this distance is D2 dash, isn't it? Let it be. Then you take maximum over D1 dash, comma D2 dash. That's what denominator. That's what denominator in Dunn index. So there are many other metrics for clustering. I hope you get the idea. Ideal clusters are like all these points. What's ideal clustering? All these points are very close. All these points are very close. And all these points are also very close. The distance, this distance, what is this? This distance is very large. This distance must be very large. This is the ideal clustering as per the Dunn index. Considering right now there are many other metrics. Remember, Dunn index is one measure. There are many other metrics or measures for clustering, for measuring how good is clustering. All of them have same core idea. The core idea is same. The core idea is same. We want to have low intra-cluster distance and you want to have high inter-cluster distance. It is a core idea. This is a core or crux idea in clustering. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.